dear students, this is Ms. Shayma Gharib and today's lesson about quadrilaterals. Let's start by revising some rules before you watch any video. You have to sit in a quiet place. You should have your pen and a piece of paper to take notes and to solve questions. You should pause the video after each question, then you try to answer on your own. Then you play the video to check your answer and to understand the question in case you get a wrong answer. Are you ready? Let's start. Quadrilaterals. What are quadrilaterals? They are 2D shapes that have 4 sides, 4 angles, and 4 vertices, such as square, rectangle, parallelogram, isosceles trapezium or trapezium, rhombus, and kite. So any 2D shape that has 4 sides, 4 angles, 4 vertices is a quadrilateral. And these are the famous quadrilaterals that we are going to talk about in details in the coming slides. Diagonals. Let's talk about the meaning of diagonals. Diagonals are lines that connect each 2 opposite vertices. We can also say they are lines that connect 2 opposite corners. For example, in the square, as you can see, we can connect this vertex with this vertex. They are opposite to each other. So this line is called a diagonal. So we can also have another diagonal on the other 2 corners or 2 vertices. So the square has 2 diagonals, as you can see. What about the rectangle? We can connect the opposite corners to find out how many diagonals does it have. It has 2 diagonals. And what about the parallelogram? 2 opposite vertices. So we'll be having 2 diagonals as well. Let's check isosceles trapezium. This vertex is the opposite to this one, and this one is the opposite to this one. Now let's connect opposite vertices and see. It also has 2 diagonals. The rhombus, this vertex is opposite to this one, and this vertex is opposite to this one. So we have also 2 diagonals. What about the kite? This vertex is opposite to this one, and this vertex is opposite to this one. So we have 2 diagonals. So we can say that all quadrilaterals have 2 diagonals. Is this clear? Now, let's look at these quadrilaterals and check. Diagonals are equal in which of these quadrilaterals? Let's start by the square. Look at the first diagonal and the second diagonal. Are they equal? Yes, they are exactly the same length. What about the rectangle? Look at these 2 diagonals. Are they equal in length? Yes, exactly. What about the parallelogram? This is a diagonal and this is another diagonal. Are they equal in length? No. This one is shorter than this one. What about the isosceles trapezium here? Look at this one and this one. They are equal. What about the rhombus? This one is longer than this one, so they are not equal. What about the kite? This one is longer than this one, so they are not equal. So we can say that diagonals are equal in the square, the rectangle, and the isosceles trapezium. Is this clear? Now, let's see. Diagonals are perpendicular. What the meaning of perpendicular? When we have perpendicular lines, it means they meet at a right angle. Now let's see. Do you see any right angle between diagonals in all of these quadrilaterals? I can identify two clear perpendicular diagonals. In the rhombus, as you can see, it's a right angle here. The two diagonals meet at right angles. And in the kite as well, the two diagonals meet at a right angle. So can you find any other quadrilateral with two perpendicular diagonals? Let's check together. Is this angle a right angle in the isosceles trapezium? No. It's so clear it's an acute angle. What about the parallelogram? Look at this angle. Is it a right angle? No. What about the rectangle? Is it a right angle? No. What about the square? What do you see? The two diagonals meet at a right angle. I will show you exactly. This is a right angle here. Can you see it? And this is right angle. And this one as well. And this one as well. Is this clear now? So we can say that diagonals are perpendicular in square, rhombus, and kite. Is this clear? Now, diagonals bisect each other. What the meaning of bisect? Bisect means cut or divide into two equal parts. So, if the two diagonals cut each other or divide each other into two equal parts, they are called bisect each other. Is this clear? Now let's check. In the square, look at this part here of this diagonal, exactly the same in length as the other part of this diagonal. And what about the other diagonal? This part is exactly the same as the other half. So diagonals bisect each other. What about the rectangle? This one, this part of this diagonal equals to this part of this diagonal. And this part of this diagonal is equal to this part of this diagonal. So they bisect each other in the rectangle. What about the parallelogram? This part exactly the same as this part, and this part exactly the same as this part. But I draw here two dashes because this one is not equal to this one. Is this clear? So they bisect each other in the parallelogram as well. What about the isosceles trapezium? What do you think? Is this part equal to the other part of the diagonal? No, they are not equal. They are different. Is this part equal to this part? No, this part is shorter than this part. So they are not equal to each other, so they don't bisect each other in the isosceles trapezium. What about the rhombus? Look at the rhombus. This one equal to this part, and this part is equal to this part. So they bisect each other. These two parts are equal in length, and these two parts are equal in length. But this one is different than this one because diagonals are not equal in the rhombus. What about the kite? In the kite, this part is equal to this one. But is the other diagonal cut into two equal parts? What do you think? Is this part equal to this one? No. So we cannot say that the diagonals bisect each other in the kite. No. So diagonals bisect each other in the square, rectangle, and what do you think? Parallelogram and the rhombus. Is this clear? Okay, now let's talk about properties of quadrilaterals. When I want to describe a quadrilateral, I have to mention its famous properties. What are these properties or features? Let's see. The most important feature to be mentioned is lines of symmetry. And how many lines of symmetry does this quadrilateral have? Okay. We can also describe the pairs of parallel sides. And what the meaning of the word pair? Pair means two sides. Okay. We can also talk about pairs of equal sides. And we can also talk about pairs of equal angles and number of right angles and diagonals of the quadrilateral. Are they equal, perpendicular, or bisect? Is this clear how we describe quadrilateral? By talking about all these properties. Now, let's check properties of quadrilaterals in details. Let's start by properties of the square and the rectangle. This is the square, so we can say in the square, all sides are equal. All the sides are equal. Or we can say 4 equal sides. 2 pairs of parallel sides. I use the word pairs to describe parallel and equal sides in case of different equal sides. What the meaning of 2 pairs here? Look at this side and this side. They are parallel to each other. They are one pair. And another pair here, this side, is parallel to this side. So in total, I have 2 pairs of parallel sides. Do you remember the meaning of parallel? Lines that never meet. Lines that are the same distance apart. Is this clear? So when I describe parallel sides, I use the word pairs. Next, angles. All angles here are, do you remember? Right angles. The 4 angles of the square are right angles. It has 2 equal and perpendicular diagonals. Do you remember? This is a diagonal and this is the other diagonal, and both are equal and perpendicular. They form right angles. Is this clear? It's really important to draw each of the quadrilaterals and write its name and list all the properties that you can mention. Study them all with drawing. And also it has 4 lines of symmetry. Where are the lines of symmetry? The 2 diagonals of the square are 2 lines of symmetry. They are the same as 2 of the lines of symmetry of the square. And where are the other 2? Here it is. We have 1, 2, 3, and 4 lines of symmetry for the square. Is this clear? Now let's talk about the rectangle. In the rectangle, 2 pairs of equal sides. I don't say two equal sides. No, two pairs of equal sides. This side is equal to this side, and we call them one pair. And this side is equal to this side, and we call it one pair. So in total, we have two pairs of equal sides. Two pairs of parallel sides. Also, this side is parallel to this one, and this is one pair, and this side is parallel to this one, and this is another pair. So two pairs of parallel sides. All angles are right angles, same as the square. It has two lines of symmetry, the red ones here. These are the two lines of symmetry of the rectangle, and it has equal diagonals, and diagonals bisect each other. Here are the two diagonals. They are equal and they bisect each other. Now, let's talk about properties of the rhombus and the kite. In the rhombus, all sides are equal, same as what? Same as the square. So all the sides are equal. No right angles, and this is the difference between the rhombus and the square. Both have equal sides, all sides are equal, but in the rhombus, no right angles. In the square, 4 right angles. Two pairs of parallel sides. Look at these two sides. This one and this one are parallel, and this one and this one are parallel. So we have two pairs of parallel sides and two pairs of equal angles. Opposite angles here are equal. This angle is an acute angle, and it's exactly the same size as the opposite one. These two angles are equal in size. What about the other two? This one and this one are opposite to each other, and they are equal in size. So we can say that it has two pairs of equal angles. This is one pair and this is another pair. Lines of symmetry, it has two lines of symmetry. This one and this one. Diagonals are perpendicular and bisect each other. The diagonals of the rhombus, same as the lines of symmetry of the rhombus. Same lines exactly. Is this clear? And they form right angles, as we said, and they bisect each other. Now, let's talk about the kite. In the kite, there are two pairs of equal sides. This side is equal to this one, and this one is equal to this one. But these two sides are not opposite to each other. They are adjacent to each other. And these two are adjacent to each other. So we can say that the kite has two pairs of equal adjacent sides. Is this clear? It may have one right angle or no right angles at all. In this kite, there are no right angles, but sometimes kite could have one right angle. It could be up here. Okay? This one. And sometimes it could have two right angles as well on both sides here. Is this clear? Lines of symmetry. The kite has only one line of symmetry, which is this line here. We can also consider it a diagonal of the kite. And it has no parallel sides. And please remember that the kite is the only quadrilateral that has no parallel sides. So when you see the word no parallel sides, you have to know immediately that it is about the kite. Is this clear? Diagonals are perpendicular. So this is one of the diagonals and this is the other diagonal, and they are perpendicular, as you can see and as we said before. Is this clear now? Now let's talk about properties of the parallelogram. Here it is. This is the parallelogram. In the parallelogram, there are two pairs of equal sides. This side is equal to this one, and this one is equal to this one. So opposite sides are equal, and we say two pairs of equal sides. Two pairs of parallel sides as well. So this side is equal and parallel to this one, and this one is equal and parallel to this one. So it has two pairs of parallel sides. Angles, no right angles in the parallelogram. So it has two acute angles and two obtuse angles. Two pairs of equal angles. These two acute angles are equal in size, and these two obtuse angles are equal in size. Is this clear? So it has two pairs of equal angles. It has no lines of symmetry. So the parallelogram has no lines of symmetry. Diagonals bisect each other, and they are not equal. Is this clear? As you can see, they bisect each other, but they are not equal. This one is shorter than this one. Now, let's talk about properties of the trapezium. There are many types or many shapes of the trapezium. Let's talk about the first one here. It's called isosceles trapezium because it has two equal sides, as you can see here. Okay? In the isosceles trapezium and in any type of trapeziums, there is only one pair of parallel sides. So when you see the sentence, one pair of parallel sides, you have to know immediately they are talking about the trapezium. And it has two equal sides, as we said. That's why we call it isosceles trapezium. No right angles. One line of symmetry. And where is this line of symmetry? Here it is. And of course, it has diagonals, same as all the quadrilaterals. It has two diagonals, as we know. These are the two diagonals of this trapezium. What about this type? Look at the shape here. What do you notice? What is the difference? The only common property here, as we said, all trapeziums have only one pair of parallel sides. There are two right angles, as you can see here. It could have two equal sides, and it has zero lines of symmetry. The two equal sides could be the sides of any of the right angles. It could be this side and this side, or this side and this side. Okay? And it's a non-symmetrical shape because it has no lines of symmetry. What about the type C here? As we said, all trapeziums have one pair of parallel sides. This side is parallel. Let me complete it as is parallel to this side. And in this one, this side is parallel to this one. And in this trapezium, this side is parallel to this one. So all trapeziums have only one pair of parallel sides. No equal sides in this shape at all, and no right angles at all, and no lines of symmetry, so it's non-symmetrical shape. Now, are you ready for questions? I want all of you to get ready and to study all the properties of all the quadrilaterals before we start the question. Who am I? Question. Look at the first sentence. I am a quadrilateral with 4 equal sides and 4 lines of symmetry. What is this quadrilateral? Square. I am a quadrilateral with 1 pair of parallel sides. We said if I have a quadrilateral with only 1 pair of parallel sides, I don't need to complete the sentence because it is trapezium. What type of trapeziums? It says 2 equal sides. The only type that has 2 equal sides is an isosceles trapezium. Is this clear? Next, I am a quadrilateral with no equal sides. What do you think? A quadrilateral with no equal sides at all. Trapezium. Is this clear? So one of the trapeziums is called the isosceles trapezium because it has 2 equal sides, but if there is no equal sides, so it will be just trapezium. Is this clear? I am a quadrilateral with 2 pairs of equal sides and 4 right angles. So 4 right angles means square or rectangle. 2 pairs of equal sides means rectangle because in the square, all sides are equal. Is this clear? I am a quadrilateral with equal and perpendicular diagonals. So diagonals are equal and perpendicular. So which quadrilateral is it? Square. I am a quadrilateral with perpendicular diagonals and 2 lines of symmetry. Perpendicular diagonals are in the square, the kite, and the rhombus. Which of these quadrilaterals has only 2 lines of symmetry? The kite has 1, the square has 4, but the rhombus has 2. So this sentence describes the rhombus. I am a quadrilateral with perpendicular diagonals and 1 line of symmetry. We just said perpendicular diagonals are in square, rhombus, and kite. The rhombus has 2 lines of symmetry, the square has 4 lines of symmetry, but the kite has 1 line of symmetry. So the answer will be the kite. I am a quadrilateral with 2 lines of symmetry and 4 equal sides. So 4 equal sides means it's a square or a rhombus. Which one of them has 2 lines of symmetry? The rhombus. I am a quadrilateral with no parallel sides. What did we say about no parallel sides? When I see no parallel sides, it means the kite, because it is the only quadrilateral with no parallel sides. I am a quadrilateral with 4 equal sides and no right angles. 4 equal sides means square or rhombus. Which one of them has no right angles? The rhombus. This is the end of our lesson today. I hope you enjoyed the video, and if you have any question, please feel free to leave a comment and I will answer you as soon as possible. Please remember that your feedback is highly appreciated. Thank you very much and have a nice day.